I want to put a question out to all of us math teachers. When we're working with struggling math students, students who might not catch on to complex concepts very quickly, how do we tackle those topics? What do we resort to? Do we resort to formulas like y equals mx plus b for a slope-intercept equation? Or do we teach the structure of the equation? And for years, I was taught y equals mx plus b, and I taught it this way my first several years of teaching, especially when I had struggling math students. There are songs about y equals mx plus b. They're set to YMCA and various tunes, and there are all these kinds of hand motions. So you can get the whole body, like that whole brain teaching involved in the formula y equals mx plus b. Y is your dependent variable, m is your slope, x is the independent variable, and b is your y-intercept. But what I found year after year is my students still struggled with the concept of a linear equation, and you get frustrated, and you're like, have I not already taught this? There must be something wrong with these students, that some of them get it and some of them don't. Who are the ones who get it? The ones who memorize. Memorizers do really well in most of our math classes, but the ones who need to understand math, understand the structure of an expression or an equation, tend to not perform very well. And if you think about it over here, there are a couple of standards in the Common Core Math Standards for high school that require students to understand the structure of an expression or an equation. Do they understand that you're taking your rate of change, this pattern that occurs multiple times, and you're multiplying it by your independent variable, and then we're adding an initial amount. It's the amount of value that occurs only once in the whole pattern. How are we teaching? Well, about probably 8 years ago, no, probably more than 10. About 10 years ago, I switched to teaching the structure of linear equations and other equations. And what I noticed, my students had so much better understanding. Their grades were better. They retained the information longer. Students who might have struggled in mathematics classrooms before mine didn't struggle anymore. And I began to wonder, why did they struggle in the first place? Well, it's because they're not a memorizing student. So when it comes to like complex vocabulary in science class, they may have a problem with that because they don't memorize well. But they can understand the complexities of mathematics when they were taught to understand the structure. So where this used to be the go-to, now I don't even teach y equals mx plus b until the very end of the unit. We're just sort of summarizing everything we already know, and usually in 8th grade after multiple units of linear equations. Since so much of our year is linear equations, we might bring up y equals mx plus b just as a summary, but it is not their understanding. I have multiple lessons out there on betterlesson.com that are free, and they help students understand the structure. So here's how sweet it is. I bring them Skittles. And so there's an initial amount of Skittles in the cup, usually 7. And I come by and I deposit 3 more every single time that I come by and make a deposit. So they begin to see this initial amount is 7, but the pattern of change is different. It's add 3, then add 3 again, add 3 again, add 3 again, add 3 again. So the pattern goes 7 plus 3 plus 6 plus 9, and so on. So they see the pattern of the initial amount, the rate of change, and then of course I throw at them the very questions that will help me to see if they understand the difference between the 7, that is the initial amount, and the pattern of change, which is the plus 3 linear pattern, by asking them how many they would have if I deposited 10 times, which if they take their total in the 5th term and double it, they do not understand the difference between starting with 7 in the cup once versus starting with 7 in the cup twice, which is what happens when you just double the 5th total. Also, again, 25. Some of them take their total amount for the 5th deposit and they multiply it by 5 because they don't understand the difference between an initial amount that occurs only once. You should add it or subtract it because it only affects the total once, and a pattern of change that does affect the total amount multiple times. So I give them a hands-on, tangible situation. give them lots of ways that they could mess that up if they do not understand the difference between that, M and B that we like to call it so many times. And then we get into, okay, so now come up with your equation. And then later I start comparing it. Some of our students compare in multiple forms. So we compare to Martha. Then we compare with Greg, so tables and equations. Then we have two different people. And now you're not comparing with yourself, you're comparing these two people. And every single time I allow students to work on this in their small group, and then we come together and discuss it, I ask them, what does this 26 mean? Why is it only being added once? What does this 3D mean? What part of this whole, candy process was the 3 representing? Why are you multiplying by 3? You add the 26 because that was the initial amount in the cup. How many times did I hand you a cup? Once. Why are we multiplying by 3 every deposit? Because the pattern was add 3, add 3, add 3, add 3 multiple times. You ask them these questions the entire unit for every single person. And I have multiple versions of this activity. That's more tables. This is tables. Of course, then I begin skipping by 2s. I only bring them a total amount every 2 deposits, not every 1. There are so many ways you can differentiate this lesson by allowing them to count every deposit, only letting them count every 2 deposits. Sometimes I shake the cup, and they're not allowed to count the first 7. They can only count the total after I deposit candy, and then they have to go backwards to the initial amount. Those are for your more advanced students. This one I made graphs, so they're comparing more with equations and graphs, if that's your focus. But this kind of activity, and then another one, again, this is also on betterlesson.com for me if you want to see it, is Jump Frog Jump, where a frog has a starting lily pad, and then they jump with a certain pattern. Jump forwards 4 lily pads at a time, or they jump forwards 5 lily pads at a time. So they very distinctly see that initial starting point and the pattern of change. And it works them through creating these equations to predict landings further down the road. Where would they be on the 7th hop, on the 18th hop, on the 21st hop, without literally hopping a frog down the number line? And then they get into tables and turning these tables and these patterns from a table into an equation. And so I have lots of activities in Better Lesson. There are lots of them on the internet, period, that teach students about the structure of a linear pattern. You could do this with exponential patterns, with quadratic patterns. Understand the structure of the equation, not just memorize a formula. Memorizing a formula might get them through a test, but understanding structure will get them through every math class from here on. And here's a clue that took me several years to learn. Students who struggle in math usually struggle because we turn math into something so convoluted, they feel like they have to memorize it, and that's their struggle. They can't memorize everything. It's too overwhelming. We need to simplify the math into what it means so that it feels like pieces of a puzzle that they have the ability to fit together in their mind, because we give them time, the right kinds of activities, the right kinds of hands-on, and the kind of discussion that helps them make sense of math, not turn it into some weird hands movements and song that just sort of gets them by. So that's my 2 cents on that question. Should you teach structure or formula? I am all about structure. If you want to bring in a formula at the end, fine. But I wouldn't make that the focus, and I certainly wouldn't begin there. Just me speaking from experience.